I am going to be drawing out some situations for us, and then we're going to put some into our calculators, and then we're going to solve some algebraically. Speaker mode. That's what we're going to be doing. Okay. So this again is going to be solving quadratic systems. First thing I'm going to do is sketch out the situations of a parabola and a line intersecting. Okay. Because if we're dealing with lines, just as a reminder, and I'm going to erase this because we're not talking about lines, but if we're dealing with lines, we could have two lines intersecting at a single point and we get 1 point of intersection. We could have had two lines being parallel and we had no solution. We could have had two lines on top of each other, and those are called coinciding lines, and every point on the line is a solution. Those are kind of like our three situations with lines, okay? We have three situations with parabolas and a line, okay? So for this, what we're going to see is the following. Maybe we have a situation where we have a parabola, and I'm just going to emphasize that that's the vertex there. And we have a line that maybe is horizontal below it, or maybe it's below it, but not at an angle that's going to cross it. And so in this situation, we would have no solution because they're not going to cross. We might also have a parabola. Draw a better parabola. I was going to steal this one. Okay, we might also have a parabola. And we have a line, but maybe the line goes maybe vertically like this through it, or maybe horizontally and it touches at the vertex, and we have 1 point of intersection. So we're going to have one solution. We might also have a situation where we have a parabola and we have a line, and it could be going horizontally through it or diagonally through it, but it ends up crossing at two different places, and we get two solutions. So unlike a line where we're going to get no solutions or one solution, or it's the same line, we could get two solutions. We never get two solutions only with two lines, never. Now, we also might have a situation where we have two parabolas. Okay, so let's say we have a parabola, and let's say we have another one in a different color. And let's say that, I'm just going to put it like below it, where one's opening up, one's opening down, and their vertices are not such a way that they're ever going to be crossing. So this is going to end up being a situation with no solution. Now, I could have a situation where I have a parabola and I have the other parabola, but maybe their vertex touches at one spot. And maybe then I'm going to have one solution. I could also have a situation, I'll grab this one too. Oops, where maybe I have a parabola, and let me move it down a little bit. And maybe anywhere that I'm moving it here, okay, I'll just put it like this just to make it more basic. You see that it crosses in 2 spots, okay? But you can see as I'm moving this around, I could have across none, I could have across 1, I could have across 2 as I'm moving it around in different spots. I'm just going to put it like this. And I get, whoops, 2 solutions. Okay, those are kind of the situations that we're going to see. So what happens is sometimes people forget the second solution for these. So you want to be careful when you're doing your math on some of these problems. So what I want us to do is I'm going to write an equation here for us, but we're going to be putting it into our graphing calculator. Okay, I'm just going to write it here so you guys see it, but you guys don't need to put this equation into your calculator. I mean, into your composition book. So I'm just writing this for you guys to see. So let's say that we have y, I'll put f of x equal, okay, so this is just for you guys to put in your calculator, put in calculator, and we're going to see how many times it crosses and see if we can find the points of intersection. So let's say we had f of x is equal to x squared minus 2x minus 8. And we have g of x is equal to negative 2.5x minus 3. Now we could graph these by hand and see, but we're going to put them into the graphing calculator. Does everyone know how to put these into the graphing calculator? So I'm going to change the screen for a second so that you guys can see how to do this. So let's see. The y equal button is right here. Okay, so you press the y equal. It gives you this. And we're going to enter in our equations. And so to get your x, you come here to this x. You don't press the alpha. You just press this x. And you're going to go x squared. And the x squared button one more time is right here. Okay. And then you're going to type in minus 2x minus 8. Then I'm going to enter in the second equation, which is a negative, and you want to be careful. You're putting in the negative from down here, okay, not a minus, negative down here. And so you're going to type in negative 2.5 x minus 3. And we get this, okay? Now, anytime you're graphing, what I want you guys to do is, especially if you're using my calculators from, you don't know who was on it last in terms of where they were, always go to Zoom. So we're going to go to Zoom right here. And when we press Zoom, we want number 6, which is Zoom standard. This gets your graph from negative 10 to 10 on the X and the Y axis. You can just literally press the number 6. I'm going to arrow down so you see this is the one I'm on. But if I press 6, it'll take me here and it'll open it up as a graph. Okay, so Zoom and then Zoom standard. And I get this. Focus a little more. And you see that this one happens across in 2 spots. These calculators do find your point of intersection. Now, if I'm graphing this, maybe I land on a nice point, maybe I don't. Maybe I have to approximate. So we're going to learn how to algebraically do this, okay? So to find these on your calculator, we want to go to, on this trace button, we want calculate, which is blue. So we're going to press second and the trace button for the word calculate. Okay, second and the trace button. And when we do, it gives us these options. We want number 5. And again, you can just arrow down to number 5. I mean, not arrow down, just press 5. And we want intersect. So again, I went second. And the trace button for the word calculate took me to the screen, and we want number 5. When I press this, it's going to usually start on at my y-axis, okay, on one of the curves, usually your first curve. I want to move this cursor to one of the points of intersection. I'm going to move it to the one right here. Now, when I'm moving, just so you guys understand, I want to use the left-right buttons. If I do the up-down, it jumps me from one graph to the other. So right now I'm on my parabola, which is kind of blue. But if I hit my up or down, it takes me to the other curve, or in this case, line. Okay, so I want to go left or right. So I'm going to arrow to the right. And you don't need to be perfect. Just get near that point of intersection. You hit enter. Right now I'm on my parabola, my blue one. Right now it's going to, when I hit enter, it's going to jump to my red one, which is my line. Okay, and it keeps the same X, and it just goes to the Y value that goes with that particular X that you just were on. So here's the second curve. You just hit enter one more time. Then it gives a guess. Hit one more time. And then it'll give us the point of intersection. Now this one, if I was graphing, I would have nicely seen 2, -8. That one I probably would have landed on, depending on if I was being accurate with my parabola. Okay. Now, to find the other point of intersection, I am going to do the same thing. I am going to hit second, the blue second button, and the trace button for the word calculate. I'm going to come down again to number 5. You guys can just press 5. I'm going to arrow so everyone sees that's the one I'm on, number 5. This time I want to get to this one over here. And to get to that, right now I'm on the curve. So it's going to take me a little bit of time to get there. So I usually jump up by hitting either up or down to jump onto the line. And then I take the line. The line gets me there quicker. Okay, it doesn't matter which one you're on. Hit enter. Hit enter again. Hit enter a third time after guess. And then you see this one is a -2.5, 3.25. That's one I never would have guessed on a graph. Does that make sense? That would have been definitely an approximation. I wouldn't have found that exactly. So you want to make sure that you know how to do this. It's a nice tool. We're going to be algebraically doing it, but I want to make sure we know how to use these calculators. They do a lot of things for us, and most of us only know how to do kind of the basics on it. So let's try this one in our calculators. And again, this answer was what we get, 2, -8, and just jotting it down for myself. And the other one was a -2.5, 3.25, and that was from our graph. Okay. So the next one I want you guys to put into your calculator is y equal 2x squared minus 5x and y equal 2/3 x minus 4. So we're going to put both of those into our calculator. So I'm going to go back to my y equal. I'm going to clear these. I'm going to enter in 2x squared minus 5x. Now, to get the second one, to enter in the fraction, hit alpha y equal, and it'll give me fraction. If you have an older calculator, go parenthesis 2 divided by 3, close your parenthesis. Okay, parenthesis 2 divided by 3, close your parenthesis if you have an older calculator that doesn't have the fraction button. And then again, we don't have to do the zoom 6 if we've already done that zoom 6. If I've already done it once, I can just hit graph. It's going to hit the graph button. And I get this. So this example, how many times does it cross? It might appear that it crosses one spot. Looks like one spot, right? There's a way to kind of zoom in on these. There's a couple of ways. The way I'm going to have it zoom in, let me just refocus this. I am going to go to this zoom button on the calculator. Okay. Zoom on our calculator. And I'm going to come to zoom box. Zoom box. And then it's going to give me this little cursor that's this little cursor there. And that's going to be a corner of my box. I'm going to move it. And I want to make sure that I'm getting this into my screen, into my box. So I want to be close to this, but I want to make sure that when I get to where maybe I want my top corner of my box to be, I'm going to hit enter. And then I can go down and out. And I can make a little box. I'm going to go up a little. Because really what I want is where it's crossing. That's what I want, where it's crossing. And then that's going to become my screen. That's going to become my screen. So I hit enter when I get it to where I want. And I can always do it again if I didn't get where I exactly perfect. And I hit enter. And then that becomes my screen on my calculator. Hard to really tell maybe what's going on there. So maybe I go in one more time. Maybe you guys did better than me. So I'm going to do a zoom box again. I'm going to hit zoom and number 1 for a zoom box. I'm going to make sure that I get where it's crossing in or where I think it's crossing in to my graph. Make sure I get that whole little section into my graph. Hit enter one more time. And it actually was crossing at 2 points. There were actually 2 points of intersection. So sometimes if you're putting it in your graphing calculator, it's hard to see it. You want to make sure you zoom and don't just assume, okay? Now, if I want to find those points of intersection, I can still hit that second button and trace for the calculate, come to number 5, and I'm going to come over here to one of these points of intersection, hit enter, hit enter, hit enter. And I got 1.3 repeating, comma, negative 3.1 repeating. Never would have guessed that, right? So for this one, I got negative, not negative, sorry. 1.3 repeating, comma, negative 3.1 repeating was one answer. To get to the other one, again, I can do second and calc again. Come to number 1, not number 1, sorry, second and calc again. I want number 5, intersect. I'm going to hop up to the line and go on the line instead of on the curve. So I just arrowed up. Hit enter. Hit enter. And this one's actually more decent. 1.5, comma, negative 3. You see how one was negative 3.1 repeating and the other one, the Y was negative 3. It's hard to really see that. They're very, very close on the graph, okay? So let me just jot my other one down. So the other one was 1.5, negative 3. 1.5, -3, and those are my points of intersection. Now, graphing's not always the best way. So the next examples we're going to do algebraically. Okay, we're going to do these algebraically. So I'm going to give us 2 for us to do algebraically. So solve algebraically. Algebraically is more precise. I will get the answer, even if it's a decimal or a fraction or something like that, I'll be able to find it. So first one. F of x is equal to x squared plus 3x plus 5. G of x is equal to -2x minus 1. I'm going to jot the second one down over here. I'm going to do both of them here. The second one I'm going to do, I'll write that one as y equal x squared and y equal 4x minus 7. We're going to solve both of these. Okay. Now, in both of these cases, they're both equal values, f of x and g of x, that's really just y. So in integrated one, we learned 3 ways. Equal values, when they're both like y equal. Substitution, if one's y equal and the other one's not. Elimination, if they're both like in standard form, which these are not. So we are going to do for both of these equal values. That's the method we're going to use for both of these. They're both going to be equal values. So I'm going to set them equal to each other. So I am going to take x squared plus 3x plus 5 and set it equal to -2x minus 1. That's what I'm going to do. Okay. I'm going to zoom in on this one right now for us. And now I'm going to solve this. When I'm solving these, I want it, when it's a quadratic like this, I want everything on one side, 0 on the other side. I always want my x squared positive too. So whatever side my x squared is going to be positive, that's the side I want to take it to. Okay. So this is okay. It's a positive x squared. So I'm going to add 2x, which means I get a 5x. I'm going to add 1, which means I get a 6 equal 0. Now this is what I'm solving. So to solve this, I can factor this. What multiplies to 6 and adds to 5? Well, 2 and 3. So this is going to be an x plus 2 times x plus 3 equals 0. I'm going to get a -2. I'm going to get a -3. We're getting 2 x's. We have 2 points of intersection. We need to also find our y that goes with both of them. Now, I can plug it into either equation. I'm going to plug it into the one, I'm going to plug it into this one. I think that's the easier equation to plug it into. Okay, doesn't matter which one. So I am going to go y equals -2 times -2 minus 1. Move it up a little bit. I get y is equal to 4 minus 1. Y is equal to 3. The other one, again, I'm putting it into -2x minus 1. So -2 times -3 minus 1. I get 6 minus 1. I get 5. So I have 2 points of intersection. One of them is -2, 3, and the other one is -3, 5. So you want to make sure you find both solutions, both x's and both y's that correspond with them. Give them to me as points. And then we're going to look at the next one real quick. And then we're going to take our quiz. So on this one, I'm going to do the same thing. I'm going to do equal values. I'm going to go x squared is equal to 4x minus 7. In this case, I'm going to bring everything over with my x squared. So I am going to minus 4x, add 7 and get 0. This one's not factorable. There's nothing nice that multiplies to 7 and adds to negative 4. We're either going to use quadratic formula or completing the square. Doesn't mean there's not an answer. It means it's just not going to be a nice answer. Okay. So for this one, I'm going to complete the square. X squared minus 4x. I'm actually going to take that negative 7 back to the other side. I am going to take half of my b and then square it. So my b is that negative 4. If I take half of negative 4, I get negative 2. If I square negative 2, I get 4. That's what I would add to both sides to complete that square. Okay. So now when I write this out, I'm going to have x minus 2 squared. And again, it's always going to be half of your b. Half of my b is negative 2 is equal to negative 3. I take the square root of this. I get a plus and minus, and because it's a negative, I actually get I square root 3. If that was a positive number, I would get a real solution, just be irrational. Okay, but in this case, I'm getting imaginary. I'm going to add 2 to both sides. Now, what this means is this is a situation where these two graphs did not cross. Does that happen every time you can't factor it? No. This just happened to be a negative 3. If that had been a positive 3, it would have crossed at 2 irrational numbers. So this one is no solution, does not cross. Okay, so you might see that happen every so often.